Hello students, today we are going to find the centroid. The centroid of a triangle. The centroid of a triangle is a point of concurrency where the medians intersect. So we need to start with the triangle, and we're not going to do perpendicular bisector or angle bisector. For this construction, we need to find the medians of all three vertices. So the median is from a vertex to the midpoint of the opposite side. If I'm going to draw a median, I'm going to draw from the vertex to the midpoint of the opposite side. So in order to find the midpoint of this side, I'm going to do the perpendicular bisector construction, but I'm not going to draw the whole perpendicular bisector. I'm only going to find the middle. So I'm going to do a little whoosh here. And a little whoosh up here. I'm trying to find the midpoint of this side. Okay. You can see right here where they intersect and over here. If I was doing the perpendicular bisector, I would connect these with a nice strong line, but I'm not. I only need to know this little part right here. I'm going to make a nice strong point right there. I'm going to call it M. M is the midpoint of this opposite side. To draw the median, I'm going to connect from this vertex to the midpoint of the opposite side. Just like that. This is a median. It goes from the vertex to the midpoint of the opposite side. I'm going to do the same thing for the next two sides. I'll find the midpoint, and then I will connect from the vertex to the midpoint of the opposite side. This side is almost too long. Let's see if I can reach the midpoint. Just barely. It's gonna be really close in here. There it is, right there. And right there. Okay, it's a little hard to see this one because this side is almost too long. The midpoint, I'm going to connect here and here. The midpoint is right there. Make a nice strong point right there. I will not name it. Okay, so for the median, I'm going to connect from here across the triangle to the opposite side to the midpoint of the opposite side. That is called the median. I've constructed two medians. I'm going to do the last one. The last one, I'm going to connect from this vertex to the midpoint of the opposite side. I need to find the middle of the opposite side. Do these little constructions right here. Dog. A lot of markings in here. Easy to get a little confused, but I'm going to go from here to here. And that is the midpoint of the opposite side. I'll draw my last median, and what do you know? They meet at a point of concurrency. If you do it right, all three medians are going to meet very nicely right here. That's a point of concurrency, and that one is really has the coolest name. It is called the centroid. So there's a point of concurrency. Which just means that all three medians meet at a point. And this one is called the centroid, which I think is the coolest name. The centroid is also the coolest point because it's that balance point. If I cut this out and I balance it, it will balance perfectly on that point. So the centroid is cool because it's a balance point. The other thing that's cool about the centroid is it is exactly 2/3 of the way from a vertex to the midpoint of the opposite side. So from here to here is 2/3 of the way of the whole distance. So you can do a lot of math problems finding the lengths of these pieces inside the triangle. So if this is, for example, 6, this is 6, this has to be 3. So this is chunked into thirds. Centroids are cool.